These 5 fake olympiad problems on YouTube can be easily solved using Lambert W function. So basically in YouTube, like I've like seen a lot of times such problems, because these problems are like somehow hard to solve if we don't have access to Lambert W function. Yeah, but once we have this function in hand, it's a pretty easy problem. And in Olympiad, like we don't really ask higher topics from analysis and calculus such as Lambert W function. So these problems aren't really meant for Olympiad, but they can come, yeah, by using other techniques such as like bounding or other factorizing, approximating, or monotonicity or something like those other stuffs. Yeah, but these are calculus stuffs, and yeah, this isn't meant for Olympiad to be honest. But let us try to see like how we solve these problems. Yeah, and after these 5 problems, I will also discuss one good problem, which is a comparatively easy problem from Maths Olympiad. Okay, so before we begin, like it's necessary to know what Lambert W function is. So basically, let's say if we have fx equals to e to the power x, our f inverse x will be that will be log x. Yeah, and we call this as logarithm function. Now similarly, if we have fx equals to x e to the power x, we won't be really able to find the inverse. So in this case, its inverse is defined as Lambert W of x, and this is also known as product log function. Yeah, since there's a product, this is known as product log function. And the and now like you might be asking like what's the benefit of defining this new function. Yeah, because if it's not solvable, even the function is just defined but we won't be able to find value. But that's not the case. Using Lagrange inversion theorem, yeah, using Lagrange inversion theorem, we can find the series expansion for Lambert W of x. Yeah, and that's how we can find the value for Lambert of 2, Lambert of 3, or any other numbers. So the series expansion for Lambert W of x is sum from n equals to 1 to infinity minus n to the power n minus 1 n by n factorial x to the power n. So this is the series expansion for Lambert W of x. Yeah, and that's how it is helpful to define the inverse function as Lambert W. Yeah, because there are series for it through which you can find the values, and that's how it can be helpful. Now for this video, if we have to find Lambert W of any values, we will just use Wolfram alpha calculator. Yeah, and then yeah, this is Wolfram alpha, and then like we can easily find the values of Lambert W function. Yeah, I've done over here. So we will see that while solving the problem. Yeah. Now let us move on to the problem. Okay. Let's begin with the first problem. First problem is x to the power x cube equals to 729. Yeah. Now if we take log on both sides, we will have x cube log of x equals to 729. Yeah. Now this is e to the power 3 log x. Yeah. Now if we also make here 3 log x, yeah, and we also need to multiply other side by 3. Now this is in the function e to the power y times y. So if we just take the inverse on the other side, we will have 3 log x as Lambert W of 729 into 3. So do you get this? I think you do get this. Now the next step would be our log x would be Lambert W of 729 into 3 by 3. Yeah. And now the last step, okay, and I forgot something over here, that I did not take a log on both sides. Yeah, so this should have the log take the log, also a log over here. Okay, fine. Now x would just be e to the power uh, Lambert W of 3 times log of 729 by 3. So was it a hard problem? It was not. Like if you just have access to the Lambert W tool, like then it's not a hard problem. So such easy problems can't come in Olympiad. And now to find this value, we have to use series expansion of Lambert W or calculator, because calculator will do all of those stuff for us. Now I've already calculated this value. So Lambert W, like about the zero that's over here, like in the subscript, I will tell about it sometimes later. But for now, like just understand that Lambert W of 0 is somehow same as Lambert W, and then 3 log 729 by 3. So this value is actually equals to uh, 2.08. Yeah, or 3 to the power 2 by 3 also, anything is fine. 2.08. So x equals to 2.08 is the answer. Yeah. Now let us check if that's true or not. Again from alpha. 2.08 to the power 2.0 to the power 3, that's 729, you can see. Yeah. So yeah, the answer is correct, because we have seen that 2.08 to the power 2.08 to the power 3 is 729 and Lambert W works. Okay. Now let's go to the next problem. The next problem is this. For this problem also, we are going to use a similar approach. 2 to the power x plus x equals to 5. Now for this problem as well, what we can do is, we can first of all write the linear terms on the other side. Yeah. Now make it in this form, like 1 as 5 minus x, and then 2 to the power minus x. Now like just try to make both of these same, but first of all we need to change 2 to the power minus x as e to the power minus x ln 2, not equals to, sorry. We can change this as e to the power minus x times ln 2. Yeah. Now what's the next thing that we can do? We can basically try to make over here and here same. Yeah. So for that, we can introduce a e to the power 5 ln 2 over here. Yeah. And that will give us, also we can introduce ln 2 over in here. So let's do that same in the both side, and that will take this expression to the required form, and I will show you how. If we introduce these two terms, now we will have ln 2 times e to the power 5 ln 2 as, over here we have 5 minus x ln 2, and numerator also we will have e to the power ln 2 times 5 minus x. So now this is in the form that we want, that is, it's in the form of y e to the power y. Now we can take the Lambert W function as the inverse. So we will have 5 minus x ln 2 as Lambert W of the things over here, ln 2 times e to the power 5 ln 2. Yeah. Now after this, it's not that hard now after this. So we can basically have 5 minus x is equals to Lambert W of ln 2. Now e to the power 5 ln 2 is just 2 to the power 5. Yeah, 2 to the power 5 by divide by ln 2. Yeah. Now take ln to the other side. 5 minus Lambert W of ln 2 to the power 5 by ln 2 is equals to x, and that's the value. So like it doesn't really have the beauty in solving this problem, because we are just taking to the form using this function and just solving. Like there's really no such fun in solving these sort of problems. But yeah, this is how we solve these problems. Now, to find the value, we again use calculator. So because we are using calculator, it's not really a fun thing to do. But yeah, we are solving this problem, and its solution is over here, I guess. Okay, so pi minus lambda w to the power 5 ln 2 by ln 2. That's just 1.7156. X equals to 1.7156. And if you want to check, I have already done that. So this 2 to the power 1.71562 plus 1.7562 is equal to 5, and that works again. Let's go to next problem, this one. Yeah, 2 to the power x equals 32x. Now for this problem it will be somehow fun, because it doesn't have the decimal answers. Like it has two answers, and we will be seeing how Lambert W can give two answers, as well as it has an integer answer as well. So for this problem 8 is also a solution, I guess. Yeah, and let us see how we get that solution from Lambert W function. Now for this problem also our approach will be same, just that we can make 1 equals to, we can take it to other side, 32x times 2 to the power minus x. Now we will raise it to the power of e and log, that gives us e to the power minus x ln of 2. Yeah, and then what we can do is we can take 32 to other side, so we have 1 by 32, and also introduce a log. So ln 2 is equals to ln 2 times x e to the power minus x ln 2. Yeah, introduce a minus sign, and now these are same, it is in the form of y e to the power y again. So now you can use Lambert W function. So Lambert W of minus ln 2 by 32 is equals to minus ln 2 times x. So we get the value of x. So Lambert W of minus ln 2 by 32 by minus ln 2. Now there's something to note. Basically in previous cases we had positive values inside the Lambert W function, so like we just got a single answer. But over here in negative values, so basically if we have the negative values from minus 1 by e to 0 in this range, we can actually find two solutions. Yeah, this is just like the function arc sin x. For sin inverse 1 we can have solution as pi by 2. Yeah, also we can have solution as 5 pi by 2, and many more. Yeah, just like that, if in this range this can give two solutions. Yeah, and we denote those solutions by Lambert 0 and Lambert of minus 1. Yeah, basically Lambert 0, this works for the case minus 1 by 2 to any real number, and this is for the case of minus 1 by e to 0. Yeah, so we will have two solutions in this case, and we will denote those by Lambert 0 of minus ln 2 by 32 by minus ln 2, and the other by Lambert of minus 1 of minus ln 2 by 32 by minus ln 2. So these will be the solutions in this problem. Yeah. Now the solutions will be, again use the alpha calculator. When there's minus 1, solution is 8. Yeah, and that's a pretty good solution, you know. Sorry. And that's a pretty good solution. This one is 8. And if you check that, it will also work. 2 to the power 8 equals 32 into 8. And 32 is 2 to the power 5. And the other one is 2 to the power 3. So that works. And for Lambert of 0, the solution will be 0.0319. Okay, so that is 0.0319. And if you want to check if both of the solutions hold true, this holds true, we can see that. But if this holds true, I can again show him from the Wolfram alpha. Yeah. So if we substitute these values and subtract the other thing, we have to get 0, yeah, because uh, if we have a equals b, a minus b equals to 0. So this is value which is really close to 0. So yeah, this works. Let's go to next problem now. We have already solved 3 problems. Now it's the turn for 4th problem, 3 to the power x. The last problem is also interesting, and also I'm going to give you a new problem for practice. But first of all, let's solve this one. 3 to the power x equals to x to the power 9. So we have 3 to the power x equals to x to the power 9. Okay, now the same approach for this problem as well. 1 equals to x to the power 9 times 3 to the power minus x. Now again use e, that gives us e to the power minus x ln of 3. Yeah, and then again the same approach, but first of all we need to make this as x. Yeah, so first of all let us take a 1 by 9th root in both sides, and that will give us 1 equals to x times e to the power minus x ln 3 by 9. Yeah, and now let's try to introduce these constants over here as well, so that gives us 1 equals to x e to the power minus x ln 3 by 9, and then multiplied by minus ln 3 by 9, and also the other side minus ln 3 by 9. Yeah, and now since we have this again in the form of y to the power y, we can use Lambert inverse, sorry, Lambert function, and so Lambert of minus ln 3 by 9 is equals to, we have minus x ln 3 by 9. Yeah, and then we can find the x, because that's just 9 Lambert of minus ln 3 by 9 by ln 3 and also a negative sign. So this is the value of x, and now if we try to find this again using the Wolfram alpha, the value that we will get is, so is this the solution? No, this is not, this is the solution. Okay, so 9 times Lambert of minus ln 3 by 9 by minus ln 3. So okay, again for this case as well we have negative value. Yeah, and this value lies in the range of minus 1 by e to 0. If x value is even less than minus 1 by e, so the thing that I'm saying right now doesn't hold true. But since this value lies in this range, yeah, and yeah, so that's why we can have two answers, Lambert 0 and Lambert minus 1. And so the latest two answers will be minus 9 Lambert 0 of minus ln 3 by 9 by ln 3, and the negative, and the next is minus 9 Lambert minus 1 by minus ln 3 by 9 by ln 3. And now we saw that one of the solution is pretty cool. The Lambert minus 1 is pretty cool. That's 27. If you want to check that, if that holds true, yeah, you can. The problem is 3 to the power x equals to x to the power 9. So 3 to the power 27 is equals 27 to the power 9, and 27 equals to 3 to the power 3 into 9, and yes, this holds true. Okay, now let's come back to this problem. So the second one is just 27, and the first one will be 1.15, and this is 1.15. and if you want to see if this holds true, again use the calculator. Yeah, and the first one is x to the power 9, second one was 3 to the power x. Yeah, and we just subtracted both, so we should get 0, and yeah, that is what we get over here. Now let's go to the last problem. Yeah, the last problem is pretty exciting, interesting, and there is an iteration function. So basically if you have a repeated addition, you get a multiplication. Yeah, and if you have a repeated multiplication, you get exponentiation. Yeah, and if you have a repeated exponentiation, you get a tetration. Yeah, so basically if you have 2 to the power 2 to the power 2, this can be written as 2 tetracon 3. Yeah. Similarly, if you have 3 to the power 3 to the power 3 to the power 3 to the power 3, this is 3 to the power 5. So note that like this 3 is not the power of the whole expression. That is not the case over here. This 3 is just the power of this 3. And again, this is the power of this expression. This is the power of this expression. Because, and these two are different actually. If you have, let's say, if you have 3 to the power 3 to the power 3 and 3 to the power 3 to the power 3. These two are different actually. Because this is 3 to the power 27 and this is 3 to the power 9. Yeah. So these are not same. And this can be written as, so 3 tetracon 3 because there are 3 3's, and this is 3 tetracon 5. So that is what the tetracon symbol over here means. Let me write it. The spelling is tetracon. Okay, now since there's x a tetrad 2, so that will be x to the power x equals to 16. And after that, it's just about using the Lambert W function again. So we have x to the power x equals to 16. If we take log, we have x ln x equals to 16, ln 16, sorry. And then after this is just e to the power ln x, and this is also ln x. Now you can see that it's in the form of y ln y. So that's why ln x will be Lambert W of ln 16, and then x will be e to the power Lambert W of ln 16, and that is the answer. Now again, use the Wolfram alpha. Wolfram alpha is in fact a really powerful tool, to be honest, because other calculators might not be able to solve, but this does. 2.745, sorry. So x equals to 2.745, and that is the answer. Now if you just want to check if that's correct answer, I have already done that. 2.745 to the power 2.745 is just 16, and that's correct. Yeah. Now we have solved these problems which are not from the Olympiad, but since these invoke a special function, they seem to be hard. So people do claim these are hard Olympiad problems, but they are not. In fact, they are easy. But now I'm going to give you one problem which is similar to the concepts from Olympiad, but it's not hard again. It's somehow easy, but you need the concept of bounding, and this problem is also pretty interesting. But since this problems involves logarithms and calculator, this might not be appropriate for Olympiad, because in Olympiads we don't have calculators, yeah, to evaluate logarithms, Lambert W, or any of such. So that's why. But let me still do it because this problem is kind of interesting. This is actually equals 333. Now we want to solve for this. Yeah. Now let's say and solve for integers only. Solve for integers xyz. Previously we were doing it for real numbers. Now for integers. Let's say there's a solution which is xyz. Yeah. Now, if xyz is not in an ascending order, let's try to arrange this value in ascending order and again name them xyz. And so that will give us a condition that x should be less than equals to y should be less than equals to z. So we are basically arranging a solution pair such that the value of x is less than equals to y less than equals to z. So let us use this condition now. So what we can do is now is 3 to the power x plus 3 to the power y, and also this is for positive integers, please note that, y plus 3 to the power z. So now this will be less than or equals to 3 to the power z plus 3 to the power z plus 3 to the power z. Yeah, because x is less than equals to y less than equals to z, and this is greater than or equals to 3 to the power z. Yeah, because these values can't really be 0 because we are exponentiating. Yeah, but still I can also put a greater sign over here, but even if this is 0.001 or something like that, basically 3 to the power z will just be lesser than this expression. Yeah, that's just trivial. Now we know this value is 333, and this is greater than 3 to the power z. This is less than equals to 3 times 3 to the power z. So from this, what I can say is z is less than equals to log 3 of 333, and from this I can say that log 3 of 111 is greater than equals to z. I can take log in inequalities because log is just increasing function, so that doesn't hamper. Yeah, that doesn't really hamper. Yeah. Now, okay. Now after this, from here, if I take the logarithms, I will get that z is less than equals to 5.28, and from here I will get that z is greater than equals to 4.28. Now since g is an integer, the only option for z is to be 5. So we get the value of z. Now, so these are the concepts in Olympiad. Like basically, you can just approximate these values, I think, and you can just try to find the values using some like non-trivial ideas, but not the like hardcore formulas and calculators. That's not about Olympiads. Okay, now let's again proceed. So we have 3 to the power x plus 3 to the power y, and this is 339, 981, and 243 is equals to 333. So 3 to the power x plus 3 to the power y, that will be 0, 9, 90. Yeah. Now again we'll use the same technique. So basically 3 to the power x plus, this technique is called bounding, is less than equals to 2 times 3 to the power y and is greater than equals to 3 to the power y. Now y is less than equals to log 3 of this value over here is 90. Again, we have log 3 of 90 by 2. Yeah, because basically divide by 2 and then take log 3 is less than equals to y. So we have that y is less than equals to log 3 of 90 is 4.09, and y is greater than equals to log 3 of 45 is 3.46. The only option that we have for y is 4 because these are integers. Now we know that y is 4. So we have 3 to the power x plus 81 is equals to 90. That's why 3 to the power x is 9, so x equals to 2. Yeah. Now we have a solution that is 2, 4, 5. Yeah. But we can see that these solutions are in ascending order because that was what we assumed in the beginning. And so these are not the only solutions. 2, 4, 5. I think that was the answer. Yeah. 9, 81. Yeah. But these are not the only solutions because we can have the permutations of these solutions, which are 4, 2, 5. Yeah, 4, 5, 2, 5, 4, 2, 2, 5, 4, and 5, 2, 4. Basically, since there are 3 terms, we will have 3 factorial permutations, that is 6. Yeah, and so sorry, we have these 6 solutions, and that's what solved this problem. So I hope you find this solution helpful and nice enough, and I hope you also like got an idea about how to solve these problems which invoke Lambert W functions. Hope you got some new information and new knowledge. Hope you enjoyed this video. Thanks for watching and look forward to seeing you in upcoming videos too.